We're going through this checkpoint 16. So we went through the J is the midpoint of HL, meaning that HJ and JL are the same because that's what a midpoint means. It splits it in half. Triangle HIJ and triangle JKL are right triangles, meaning that we can use the hypotenuse leg. And then our last one we have as IJ, and they showed it in the picture, is congruent to HJ. Okay, and before I look at anything else, I just want to look at what else we've done and that we did. You could do angle. We don't have two angles. Oh, we could do angle side. So Jonathan said that we could do angle side, and we totally could. And so this is the cool but frustrating thing about proofs is, yeah, and maybe he saw this one. We could say that those two angles are the same because of vertical angles. But here's the kind of the frustrating thing. The shortcut way, I was doing the HL, and then technically HL. And the reason why that we can do HL is because of the right triangles. That's the whole thing with these, is right triangles. So let's go down here and look at the proof. So we know that the first thing is going to be given. Because you could totally write, let's see, side, angle, side. We actually could not use, Stephen, we could not, oh no, we could use side, angle, side with what we're given also. We'd have to also use vertical angles to do side, angle, side. And both, like all three of those methods. So we have hypotenuse leg, which is what this proof uses. And then you said angle, angle, side. You could do angle, angle, side because there's this angle and that angle and then that side. So you could do that one. You could do side, angle, side because you'd have this side, this angle in between them, and then that side with this side, that angle, and that side. So you actually technically have three different things that you could use to do this, which I think that's awesome for me. But if you're new starting out on this, that's super frustrating. So I'm sorry. But that's the nice thing about the way that they're doing them in this problem, on these problems, is you only have to pick out what they said and then kind of like interpret what they said. So J bisects HL. So bisects, that's what we said at the beginning. Oops, up here, if I can scroll it. We said that this bisects that thing. So that would be by definition of midpoint. So you're going to look for definition of midpoint. And then because of that, then we're going to say midpoint bisects the thing, and then those two are the same. So that's the ones that we put the two lines on, and that would be definition of bisect. Because, and we're doing that because it said bisect on this one, definition of bisect. And now because we have, and so this is the official way that they used here, is because it's a right triangle, we can use the hypotenuse is the same as the hypotenuse on this side, like the hypotenuse are the same. And then we just, the thing that we just did was this leg. This leg is the same as that leg. So the reason why we can say this one is the HL postulate, I think is what it's called. And if it's not postulate, it might be a theorem, but it's the same idea. Okay, good. Theorem, okay, I cannot remember. Because I just use them and I forget if they're a theorem or a postulate. Okay, next one. So use the triangles to answer this question. So there are two right here. So if triangle ABC is congruent with triangle DEF, so it just flat out tells us that they are the same. So in fact here, I'm just going to look at the things that they gave us. So here's this angle. It's the same as that angle. There's that angle and that angle on the picture I'm talking about. And then we have 6.5 and 6.5. So I can see that by angle, side, and that is a postulate. I know that one's a postulate. That they are congruent. So now we know that they're congruent, and we want to find what is the length of DEF. Yeah. Stephen, perfect. It is indeed that 13 because that's the part that's missing on this one. This one's 13. We don't know this side yet. and we could calculate, if we knew what those angles were, we could calculate the angles, but yeah, so that one just goes there. Okay, next part. Do you need me to wait? Okay. Next part. So again, they tell us that they are congruent, and let's just look at how they're congruent. Like, what information were they giving us? First, we can see it's a right triangle, so most likely they're going to use hypotenuse leg, and they did. So here's the hypotenuse is the same as that hypotenuse. And then here is this leg, and it's the same as that leg. So we can see that they're congruent by hypotenuse leg. And then we got to look at the other information that they gave us. So the other information, so now we want to know what the angle ACB is. So if this one right here is 34.7, that one right there also has to be not even complicated like that. Can you guys see it? It's the 34.7. Yeah. Because if this one right here is 34.7, and that's the one like at the pointiest end of this triangle, then that one also has to be, because it's the pointy end, 34.7. Okay, groovy. Next one. There are 4 questions on the check. So then we have this one, and we go through and look at what they give us. So then they have the given, but let's just go through and see what they said. Do you guys know what this symbol is, what this symbol means right here if we have 2 lines like that? Do you know what that means? So these symbols that are right there. Do you guys know what these symbols mean? Yeah, they're parallel. In fact, we're going, the next part that's coming up next is learning about parallelograms. And I like to abbreviate parallelograms because it's a long word to write. By doing parallelogram. That's just a side note saying get ready. I'm going to abbreviate like that. Okay, so AB is parallel to ED. Do you guys know the symbol for showing that they're parallel? I don't know if this course is taught that or not. Do you guys know the symbol for parallel? Yeah, it actually kind of has to do with what you guys were talking about at the end of class yesterday. It is this little arrow. You guys, now you're talking about the little up arrow, and how do you do that? So AB is parallel to ED. They do just one arrow for the first one, and then they said BC is parallel to DF, and so then you do 2 arrows. Okay. Well, good. I'm glad I taught it to you. So that's what parallel means. And so if you're ever taking a test, which I don't know if it's going to be like that on the SAT or anything like that ever, but if it is, then you'll be like, I know that. Okay, and then we have that BC is congruent to DF. So I'm going to go line and line. Got it? You can do the lines like the tick marks if they are the same length. But what we have here is not that they're the same length, but that they are parallel. So they can still be parallel and be different lengths. Like I could say that this is parallel to that, but clearly they're not the same length, right? So the tick marks themselves are what shows that. And then generally speaking, you don't put both of them at the same time. I do, because for me it helps my brain keep it make more sense. Okay, so I like to look at what we have, and then let's just keep on looking at other things about this. So I have, we want to prove those angles are the same. So we have 2 sides of this that are the same. Do we know anything about AC or EF? I don't see anything about AC or EF, so let's just look at the logic that they used. Because I would assume, because they said nothing about angles, that we're looking for something that is side, side, side. But I still don't see anything right now, just anything given, that talks about how AC is the same thing as EF. Okay, so these given. then they said that those angles were the same. So let's look and see why they could say that the angles were the same. So this is my guess on side. So they said BCA is the same thing as DFE. Okay, so let's see why they said that. If I were to take this line right here, like take BC and make it longer, and take FD and make it longer, then that means that this line that has EF, like the one that the both of them are on, that makes that a transversal. In fact, the fancy mathematical way of saying it is that is a pair of parallel lines cut by a transversal. So do you guys, this is where I don't know because I wasn't teaching this class to you guys, but do you remember learning things about, like, if it is cut by a transversal, that this angle is the same thing as that angle because they're alternate interior angles? Okay. So, Stephen, you learned it. Aaron, you learned it. And so it was all in this class? Good. Okay, so those are alternate interior angles. So it's saying that this angle right here is the same as that angle. I'll put one tick mark in it. And then it says that BAC, this angle, is the same as DEF. So DEF is that angle. And that would be because of these parallel lines also cut by the purple transversal. So both of those, the reason why those are true is because of AIA, alternate interior angles. Okay, so now that we have this, we have, see, but this is the tricky thing. So now we have these two triangles. We have ABC and EDF, and we have an angle. Oh, we have two angles, right? We have two angles, and then we have a side. We know that this side is the same as that side. So let's look on one triangle to figure out which order it was. So we have angle, 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 side. So that would be, they are the same because of the angle, angle, side. And let's just look at, so here are the two angles. The two angles. And it was that part right there, that's the side that we talked about. So when you're formulating your proofs, you're looking for, when we're saying like this final statement at the bottom, we're looking for, or like to prove that the triangles are congruent, make sure that your things here talk about the two different parts here. So we have the two angles right here, and that one, the side. Did you just do it along with us, Jonathan? Nice. Okay, so that is the checkpoint 16.